Hi campers. Today we're looking at a Selco, I think that's his Selco brand of welder. This is a inverter based welder rather than the big heavy transformer based welder. And usually with the inverter based ones you can get kits to make them TIG welders as well, so that's pretty cool. This appears to be 140 amp. It's a Genesis 140 is the model, and does not turn on. So let's poke around inside and see if we can figure out why. Got a screw, two screws on the top, and a couple of screws underneath. It looks like I have to take these end covers off first. They look like they wrap around the metal cover. Screws are out, so let's find out what gives first. That's going to come off. Maybe the bottom comes off first. Maybe. Aha. Full of dust. Split the end covers, of which the front is. I wonder if I have to take the knob off, or if that panel will come off with it. Oh, there it goes. Okay, the knob and switch come off with the front plastic. If I just move that and move that. Something attached to this as well. One ground wire attached to the chassis, as you'd expect. Take the front panel off and look a bit deeper. Funny if it was just the switch. Probably not. Why would it be that simple? So looking over here, we have the power cord comes into here, and the main switch is connected through here. So this whole top board is our power in, and I'm guessing just regulation for the rails for the controller for the lower board, which does all of the higher switching, the welding current switching. So being inverter based, it's exactly that. It's switching these capacitors. It'll be switching these capacitors via, so we've got our mains. Our mains is going to come through here to here, comes down here. There's a big fat bridge rectifier under here, and that's clamped to the heatsink. And then there is some switching transistors hiding underneath there, bolted to the heatsink, controlled by the lower board, which will be switching this voltage across a transformer to create the output. Well, I suppose I jumped the gun a bit by not switching it on to prove that it's dead. I could be having a totally different problem. So let's do that and see if any lights come on. No lights. So we know where we are. Definitely dead. So what I'll do now, switch it on, and we'll just see if where a mains voltage is coming in. And I'm going to go straight to this end of the board, because if I've got 230 volts across here, then I know that all of this in between, including the mains switch, is actually okay. So I'm going to go straight to here and see if we've got our 230 volts. Meter in AC, and we do. So hiding in there is a LM7815 voltage regulator, and I will probe that and see if we have anything on its output. We have nothing there on the output and nothing on the input. So we've got mains in, but we have no supply to our low level side, wherever that's coming from. There's another couple of possible voltage regulators standing up on there, and possibly a little switch mode power supply there. So I don't know who was last in here or if this is out of the factory, but around here there's almost no solder holding that pin to the board. Same with that one. And some of the other joints are looking pretty dodgy, one over the back here. So we'll have to tickle those up. I'm surprised the thing worked at all. So I've taken the top board off, and we're going to go over that and see what's going on, because this is where our problem is, and I'm pretty sure that we are not getting any power to this. So let's try and see where the power comes from. So we've got our mains in on the right down the bottom here, and yes, it's unplugged, safety first, and comes in through, we've got, that's earth, that's our earth. So here we got oh yeah, our big inductor. So we've got phase through the switch, comes through, then we've got phase here and neutral here. Looking on the top side, that's that there, that coil there passing through, and we have a couple of, so one side, yeah, I think our neutral comes through on the top side up to here, and our phase does, our neutral runs along the bottom side to the other pin. But where does it tap off to feed this top board? And just looking at it, I think it goes down to the bottom board and then back up. So I'm on the wrong path already. Let's see, we got, yeah, so this white connector down the bottom comes back up from the lower board and feeds what looks like a primary side of everything over here for this. So just trying to understand what's happening there. We have a transformer, secondary, primary, transistor here, and we have 3 lines coming in from the lower board. We've got 2 running down here over to our regulator 7815 that we looked at that has nothing on it, and 1 pin runs off to the primary side of this transformer. Okay, so now I'm thinking that that regulator is there to power the switching control circuit for the primary of this circuit here. And I think there's one other pin runs off on the top side. Ah, yep, through a fuse. That could be a fuse. I wonder if there, oh, there's our problem. So up through here and across to there. Interesting. Let's check that little white thing down there. I've got a feeling that that's a fuse. And it says A1, possibly 1 amp, 250 volt. There we go. And it's blowing. How about that? Alright, so because of that, I think we can assume that we do have voltage on there. It's just not getting through to the rest of the circuit. Hence our dead result. So just following the traces through, Just going to flip it back and forward and block your view completely while I try and nut this out. And we've got one capacitor there. I'm trying to follow that little capacitor there, being electrolytic and polarized. We can use its ground pin as the reference, because it's on the primary side, it's reference to ground on that side. We'll be getting I'm going to say 400 volts, 300 odd volts. So you remember how it ran across this side of the board, and these two take off down to those large red capacitors. Well, those are our main storage capacitors, and that is being tapped off and brought back up here to be switched across this transformer as a switch mode power supply, instead of having its own main filter capacitor off the mains. It's using the same one that's used, or the same 3 storage bank that's used for the whole thing. So makes perfect sense. So this is our negative. So if we check that with respect to the other side of the fuse and just see if there's a short there. So I'm going to be probing that pin, and I'm going to be probing this side of the fuse because it's blowing, so power voltage comes in through this side. We want to look at the other side, that's the load side of the fuse effectively, and see if our resistance there is of acceptable value. So let's get you looking at the meter and tell me what you see when I go from negative to positive side of the fuse. Do we have a reasonable value? And it looks like we do. So there's no reason, 95,000 ohms, that we should have a fuse blowing. So maybe that fuse has just given up from stress. I wonder if it's a thermal fuse. Might be a thermal fuse. Well, someone's been in here before. This bar has no nut on top of it. Maybe these transistors were replaced once, hence the poor soldering, or lack of, which I've just touched up, but missing a nut I just found out. So it is touching the stud, it will make connection, but it certainly won't be reliable long term, so I need to find a nut for that. So I've just stuck a normal glass fuse across here. It's a 1 amp fuse as well, and just soldered a wire from each side down to the board, so that we now have our connection across there, and as far as we can tell it shouldn't pop. Alright, we'll get you looking at the fuse, which is right here, and I will plug it in now. Okay, now I'm gonna switch it on. 3, 2, 1. She blew. Definitely a fault on the secondary side then. So we have 2 wires sets that appear to be carrying power down to the lower half, and there's obviously a fault on one of those. So let's do a check there. So just on our ohm scale, and we'll look at this one first. We've got a red and a black, so we'll just pop our leads into there and see what sort of resistance we get. So yeah, about 10,000 ohms. So let's have a look at this here. So we've got a red, and then a black, and then on the far right we've got another red. So we'll have a look at we'll go from black to the left hand red pin, and it appears we have a short circuit. If we go from the black to the right hand pin, 200 ohms. So 200 ohms sounds a lot better than a short circuit for sure. So we'll presume that 200 ohms is correct, and we need to start tracing that red wire, find out where it goes, find out what is shorted. So here's our wire, runs down here, down through the case, and up into the bottom, and into here, which is the board, funny enough, that had the poor solder joints and the missing nut. Looks like we've got some what they are, just capacitors, I think. Yeah, they're capacitors. There's our earth. This is our earth conductor. So all we need to do is follow the pin that we can't see very well. Maybe have to take the board off. Remembering that we just had this plugged in, so double checking these are discharged to a safe level that we can handle it. And this is our bridge rectifier down here, marked on the board plus and minus, so measuring across there we're down to 5 volts now, so all is okay to handle. Now listening for the beep, I'm gonna one probe on the known bad wire, red wire, and then I'm going to find out exactly which wire it is that comes down here, because there is a couple. So is it this one? No. Is it this one? No. Then there's another red wire tucks up in here and runs up into there. It looks like it comes down to the front to one of our main output terminals, which goes out to the torch. So why would that show a possible short? Is that because that negative on the same line is also connected to it? Ah, boo! So this is not our problem. Okay. Okay, I've got another fuse installed, and we're going to isolate everything and one by one plug the stuff in and see if it blows. If it doesn't blow right away, so here, this is our fan connector which goes into here. In the corner here, that's where we have the wires that ran down to the front connector, and I really do think that's used as a current shunt, and that's just measuring the welding current. And we've got, of course, this connector here that comes up to over the back here. That's where our 300 volts DC comes in for this board to run, so we have to plug that one in. Leave the fan off, and then down in the front here, this one here, that goes down to the main heatsink. That'll be our temperature sensor, 2-wire, and then here we've got a 3-wire. It's actually a shielded cable, so we've got ground and then 2 wires. Now looks like what they're doing is they have optical isolation for data transfer from the top board to the bottom board. This is a data cable, and that's used to control how the lower board, which runs the output, how that operates, and how basically how much power to generate, really. So there's that. So if I leave that unplugged, and the bottom board won't fire up, and I'll leave that corner off, so we're not measuring the output. And yeah, I hardly think the fan is going to be causing a excess current draw, but anything's possible. So, but I mean, other than that, there's not really a lot to it. It is entirely possible that the primary side has a fault. Maybe the transformer's got a shorted winding, and when it fires up, it just draws too much. And because you would think that any secondary overload might be monitored as far as the input, the primary control, because it has to monitor what it's doing to get the right output. So yeah, there's every chance it's the primary that's failed, but certainly the switching transistor looks okay, and I can't measure any low resistances anywhere. So okay, so plugging in, Now we'll turn it on. Cool. Well, that's interesting. I heard it, well, you probably heard it too. There was an oscillation. The board at the bottom, the green lights came on. I'm not sure if you caught them down in the corner, down in bottom left corner. It sounded like it was oscillating, like it was trying to generate an output, because it was uncontrolled by the top board because I didn't plug in the data line. Okay. I think I'll plug in the data line now. Sounds like a better option than the fan first. So I'm plugging in the data line. I'm going to plug in the front control as well, because I've got it turned down to the lowest setting possible. So okay, so turning on again with the data line attached. Oh, so we have a green light. We have lights on the front panel too. See down the bottom corner we have green lights. So it is currently stable. There's a red light on the top. Was that on before, or did that just come on? So we have a red light on top. Let's test the fan, and we'll test it on the bench supply and just see if it's drawing a stupid amount of current. Okay, here we go, checking fan. I've got leads into the plug, and it's set at about 12 volts. Oh, but sadly she's only drawing not even in 50 milliamps, I reckon 100 milliamps tops. Right, so now all I have connected is the fan. We've got our input voltage, we've got our temperature sensor, front panel, and I'm leaving off the sense lines, and let's turn it on. Okay, well it stayed on, but we had the bloody thing trying to run, which is not ideal. Hang on, I did put the wire back on, did I? Oops, I left the wire off. Alright, let's turn that on again. If I pull that, what I think is a sensor off, turn that on. So it doesn't try and run with that unplugged, but we don't know what that is. I wonder what voltage the fan runs at. It's got to be 12. I'm just going to have a quick look out of curiosity. Oh, we've got 18 on there. How about that? Makes me wonder if it shouldn't be 24. Fan connected, sensor disconnected. We'll see if the fan runs or if it's too much for it. Oh, fan's running, so that's okay. Alright, let's go for gold. I'm going to plug the sense line in. I'm going to plug the temp sensor in, because with the sense line plugged in it shouldn't want to fire, and since it's trying to fire without the sense line, it's not blowing the fuse then, even though all the high current demand is happening on the bottom board. So we've got everything plugged in now. Here we go. Right. Everything plugged in doesn't like it. You know what? I completely overlooked something. From the top board, this connector comes up, carries our 300 volts for the switching supply for the top board, but it has 4 wires. So not only that, but it's carrying other voltage back down to this board. So there's still every chance that this board has a fault on it, and plugging in the sense lines is purely coincidence. Since this board does all of our power semiconductors, where they tend to be things that fail because they're under high stress all the time, let's just check those. So going from I'm starting in the bottom left here, and they are, what are they, K2611. I can see the marking on them, K2611, likely all paralleled up for power demand. So it looks like that's an N-channel MOSFET. So let's have a look, see on our gate collector. Looks okay. Gate to emitter, positive on the gate, that is. That looks okay. Collector to emitter, that looks okay as well. And we're just going to run down all of them and looking for any readings that are no good, like 0, short circuit. Where am I going? I think I jumped the gun on that one. And that one. There's also one other one tucked away in the corner over here. What have we got on that one? Gate collector. Well, looks like a short circuit on the gate collector. Gate emitter. Looks like a short circuit there as well. So we need to now remove that from circuit to test it, because it could be something across the pins causing the short. However, you'd expect that across the gate collector emitter, sorry, if it's across a winding of some sort. You would not expect it from the gate to either of the others. The gate should be isolated. Now that the gate is possibly shorted through, that could very well be overloading the drive circuit, which may be enough to set off the fuse in the supply rail. And checking gate source, gate drain, and dead short. Let's have a quick check on the board itself, where it was sitting. Make sure that there's nothing going on that may have damaged other parts of the board. So that looks okay. There's a, looks like another possibly a Zener. No, it's a normal diode. There's a diode across there. That looks okay. And we'll just quickly check these other diodes in the vicinity. That one doesn't look so flash. That one's alright. That one's alright. That's alright. She's good. It's not uncommon that other parts get taken out when a FET shorts like that. But actually, just looking, is that resistor across? No, it's not across there. What about that? Does that go up to there? No. Any of these? No. Just that pin there. Alright, so possibly this diode is bad as well. We'll check that. Okay, so there's the tiny little thing, and we will check that with, I can't show you the meter, but in diode mode, positive on the anode, negative on the cathode, and I am getting a short. It's shorted, and this is a gate protection diode, I think it was. If we check the circuit again, So here we can see this is where our transistor goes in. This is the gate, and the Zener Diode comes off the gate. So if the gate voltage exceeds a certain threshold, this will conduct and protect, or try and protect it. I'd say this shorted and we got our full voltage across to the gate, which is no good at all. So this actually shorted to protect. Well, it didn't really protect a lot, but possibly it would have protected the drive circuit, sorry, yeah, so the wherever this goes to create the drive signal, that would have been protected, one hopes. I'll put the anti-static mat down for this one. These are static sensitive devices, so we may as well not encourage any problems. Static discharge can cause service failures long term. We'll get those pins bent at the same angle. Don't give us much room to get in there. It's pretty much the length of the fat section. Now that was silly. I should have done the middle one first. Let's not install the old one. Now, getting the height shouldn't matter if we drop it on the deck, because that's going to be flat enough. It's going to screw down onto the board, onto the chassis. So I sat it back on the chassis and tacked one leg in place, and while it was liquid, got the hole to line up, pop the screw down, and we'll solder these in while it's sitting there. That will give it a pretty perfect lineup. Now we'll pop the little Zener Diode on. Make sure we got some nice bit of leaded solder on there. Now this is a 20 volt Zener. Slippery little devil. I might just get that liquid and then pop it on. I'm not going to worry about screwing down all of these transistors just yet, because I want to test it, make sure it works first. So we need to put more thermal transfer compound underneath those if we do. Here we are where the fuse lives. Oh, I actually thought that was longer. Looking at it by itself, it looked a lot longer. So that should slot into there okay, and get that hot and liquid. It'll sit just enough room at the ends of the pads to hang on to it. Clean these pads up. This is really crappy solder work I've got. Doesn't actually seem to come with any flux embedded in it, so I've added a bit of flux to the board first. And that kind of works. Also, amazingly, how fast you go through cotton swabs. Feels like only a couple months ago I bought 100 of them. push it down, we'll get it wet, make sure it's sitting flat on the board. There we go. And we'll flood the other side. See it creep through there. Okay, about to switch it on. We want to see lights. We do not want to see no lights or even a brief light. This should come on, it should stay on, and it should yeah, hopefully that was all's wrong with it. We've got our transistor in, we've got our Zener in, we've got the new fuse. That's all I could see initially. Worst case, it goes bang. It's probably long. We could keep looking at it, but yeah. Now, enough talking. Here we go. 3, 2, 1. Oh. Okay, it stayed on, and I heard a small pop. Don't smell anything. Maybe it was my imagination. It didn't die, so that's a good sign, I suppose. Just a quick thought on the off chance that perhaps the rows of transistors under there that do the bulk of the work, the switching, may have to be bolted down to the metal plate underneath. It might be that that metal plate forms part of the circuit through the center pin of the transistor, and it may be that me leaving them floating just meant that it was trying to pass current through a bit of a gap, and nothing happened other than a little bit of a sparkle. We'll do a quick check across the one that we just replaced, see if that appears normal. And before I shove my meter across it, I'll just check the voltages, make sure it's drained. We'll throw off our diode readings. So gate, drain, gate, source, drain, source. No, that's absolutely normal. Our Zener Diode is absolutely normal looking. Yep, we're safe there. So now we just a quick check along these. That one, I think these are fine. I'm going to say these are fine. Yeah, I forgot about the underside. This nut is missing. So that would have been a very loose connection between this and that. And that may have arced in between that gap there as well. So, I mean, that's going to the primary or the secondary? No, it's going to the secondary of the output transformer. So it's probably that. If it did a bit of a test blip to see if it was happy with itself, let's find a nut for that, and we're almost done. Alright, let's turn this on one more time. I've got it sitting on something, bit of plastic underneath to help hold some pressure against that contact. I can't find a nut the right size. It's like 5mm. Everything I've got is 6 or bigger, so we'll have to look into that. Still don't know where that noise came from for sure, but I will turn it on again and keep a watchful eye out for any bright flashes or whatever. Cool, so no horrible noises. We'll just leave that on for a bit. Who knows? That could have been a pop as the cap's charged, as the relay clicked in, whatever, I don't know. So I'm calling that a fix. I can't test it, so I'll probably put a comment in later on if the guy comes back to me and says, yeah, sweet, but I don't have the torch, so I can't do a test weld, but it's not throwing an error code. I've got all the lights on. I'll show you. So we've got a little red light down there. If we come over the top, got a little red light down in the middle there. Got a couple of little red lights down in there. And if we have a look down the side, a couple of green lights just there. So there we go. 3 little components The fuse doesn't really count because it was a side effect, but one output transistor, it appears to control the output current, and a Zener Diode in line with that. So there we go. Thanks for watching again. Yeah, like I said, I'll come back to you and let you know if it works or not. Thanks very much. Take care.